Saxon Algebra 2, Lesson 95, more nonlinear systems. We have been working on problems where we solve a system, but it's not two lines, right? There's circles and other weird things like that, and there are squares in the equations, and we have to do some special algebraic gymnastics to make it fit, but it's fine. And we're going to continue that today, and I actually like these problems a little bit better because John gives us some more information. He says, solve this system. And then he writes 6x minus y equals 5. He tells us this is the system. And he puts the a and the b by it, as he often does, just so we can talk about them if we want as a and b. But then he does something really helpful. He writes this. He tells us what shape this equation is going to make, and that makes it so much easier for us to envision what we're doing and to see what our answer is going to look like. So what I'm going to do, I'm not going to graph this with any degree of detail, but I'm going to draw, first I'm going to draw the hyperbola. That's like the markings on a basketball. That's this one. And then a straight line, like so. And so we can see, oh, we're probably going to get 2 points of intersection, right? Now, this is not an accurate graph, but this is just a sketch that shows the most likely way that a hyperbola and a straight line could intersect. So it helps me understand there's going to be 2 answers. So now what we do is we proceed with our algebra, knowing that we're probably going to end up with a value that gives us 2 x's, and then we'll have to calculate 2 y's. Okay, we can do it. That's no big deal. Now we go back to this and go, okay, we have the fundamental problem that we often do in nonlinear systems where we really can't use elimination because the shape of these equations is so randomly different that we can't make them look like each other, which is what you have to do for elimination. In elimination, you have to shape the 2 equations so that something in them cancels out, and it's not going to work here. So we have to go for substitution. This is kind of like the easier, smaller equation. So we want to substitute that in here for either x or y, which is sad because what we'll have to do is make a fraction, but that's not the end of the world. So let's just divide both sides by y, and we'll get x equals 4 over y. Then we'll substitute that in right here, okay? So I'll get 6 times 4 over y minus y equals 5. Now before, okay, well let's multiply it. I'll do that. 24 over y minus y equals 5. Now I say, let's get rid of this denominator. Let's multiply every term on both sides, that's supposed to be a y, by y, because that is the denominator, right? And that will make that cancel. Then I'll get 24 minus y squared equals 5y. Oh, that looks much better, and I can see I've got a trinomial on my hands. So what I'm going to do is I'm going to swim everything to the right. So I'll get 0 equals positive y squared plus 5y minus 24, right? Change sides, change signs. And then just because I like the way it looks better, I'm going to move the equal 0 to the other side. I can do that. That's mechanical. That's not doing any algebra. All right, now what we're wondering is John going to make us use the man-eating dragon, or can we solve it like this? And the good news is we can solve it like this, right? Because y equals, or the numbers rather, it would be plus 8 and minus 3, right? We can solve it by inspection. Okay. So that's happy days. And we know using the 0 factor theorem that if the product is 0, then one of these guys has to be equal to 0. So either y plus 8 equals 0 or y minus 3 equals 0. And this will be y equals minus 8, and this will be y equals 3. Oh, okay, that's really good. Now, we need to find x, right? So what we'll do is we'll take this, x equals, this is in nice shape for solving for x, right? Because it's already by itself. Oh, I love when that happens. So now we can plug both of these in. I've even got space down here. If y is minus 8, then x equals 4 over minus 8. And that means x equals minus 1/2. And if y is 3, x equals 4 over 3, and that's a done deal. We can't do anything more. So to write our final answer, I'll write the first x minus 1/2 with its y minus 8, and then the other solution is 4/3, 3. That's our final answer, written in ordered pairs. And what that means, let me just double check that that's correct. 4/3, 3, and minus 1/2, minus 8, yay. What that means is that these are these 2 points. And again, I didn't graph these accurately, but it makes sense with our picture, right? That we would have 2 different places of intersection. Yay! Let me see how many examples there are in this. There are 2, so we're halfway there. Nice. All right, I hope you feel smart. Look at how challenging that is and all the weird algebra we had to do to sort it out. But there are like almost no words in this problem, so it's quite straightforward. 95.2. What do we have here, John? What have you thrown us? And we're told this is a circle. I'll let you finish copying before I say some things. When you get these equations and these systems on your page, don't worry about trying to make sense of why is this one a circle, why is this one a hyperbola? Because we just saw a problem where the hyperbola was xy equals 4, and we were told that was a hyperbola. This looks remarkably different than that. How come this one is also a hyperbola? Don't worry about that. You don't need to concern yourself with trying to understand why these nonlinear functions are named what they are. You can just take John at his word for it now. We're going to spend more time talking about these shapes next year. So for now, you can just take John at his word and don't worry about it any more than that. Now, what's fun with this one is that a circle and a hyperbola make a really complicated connection. Again, we're not graphing these, we're just sketching out the way that a circle and a hyperbola are likely to relate. And they're probably going to have 4 pairs of intersecting points. Oh my word, this is exciting. So when we get into solving for every pair of solutions, we're just going to keep in mind it's probably going to be 4. All right, now, this time we see that the shape of these 2 functions or equations, we can use the word functions and equations pretty much interchangeably. They're going to eliminate. In fact, we don't even have to reshape it. It's perfect, right? The y's are going to eliminate. So we can say that 3x squared equals 3. Oh. Okay, because this cancels, right? Divide both sides by 3. We get x squared equals 1. We take the square root and we get x equals plus and minus 1. Oh. Okay. That's cool, right? So now we're going to do our 2 sets of solutions. Over here, we'll say x equals positive 1, and here x equals negative 1, right? Just like what we did here with the 2 different values for y that we calculated at first. So we're doing the same thing here. And so what we want to do is we want to pick either one of these equations and plug our x value into it. And what I'm going to do, no, I won't. I like this one better. I like A better. It's just a little bit simpler. So what we do is we create buckets. I'm going to do this. Just it helps me see that's like I'm halfway there. X squared plus y squared equals 9. Right? I'm just copying this formula down with a bucket for the x. Here I'll put in a -1. Here I'll put in a 1. Now I'm just going to let that one wait and work this one all the way out. Okay, and so I get 1 plus y squared equals 9. I subtract the 1. I get y squared equals 8. I take the square root. I know I can simplify this because it's 2 times 2 times 2, right? So I can pull 2 of those out, and so I'll have a single 2 on the outside and a single 2 on the inside. So y equals plus or minus 2 square root of 2, okay? That means the 2 pairs of points that I get here is x1, y positive 2 square root of 2, and then x1, y minus 2 square root of 2. That's how I get 2 pairs of points out of this, is because I got a plus or minus here as well as up there. Good to know, right? So that could be like those 2 points. All right, now I'm going to work on this side. I'm going to get the same thing. This is going to be 1 plus y squared equals 9. I'm going to subtract the 1. And I'm going to get y squared, forgot to copy that, equals 8. And then I know how to simplify the square root of that because it's the very same as over here. Y equals plus or minus 2 square root of 2. I get the same answer. And at first I think, well, that's weird. But then I think, no, it's not weird, because when I squared the -1, it's exactly the same as when I squared the 1. So I'm going to get the same calculation. Now, when I write my points, though, this x has a -1 in front of it. The other x had just a positive 1. And this is -1 minus 2 square root of 2. You have to be careful checking your answers, but notice here I have positive 1s. Here I have negative 1s. 2 square root of 2 minus square root of 2. 2 square root of 2 minus square root of 2. So I think the origin would be right in the middle of this circle. We don't need to know this, but it just kind of is fun to see how this is 1 positive square root of 2, 1 negative 2 square root of 2, -1 positive square root of 2, and -1 minus 2 square root of 2. So it makes sense that they would go around in this little pattern. This is our final answer. Yay. These are just pure algebra, and I hope that you enjoy them in the way that pure algebra can be enjoyed. Yay. Thank you. Bye.